Hello everybody, my name is V. Narendra Kumar and we are from NRK Academy, and today our topic is, in the series of Physics Made Simple, our topic is our universe. So the first section is the Big Bang. Let's start. We take the world as we see it around us as the given, right? As if it was always there. But science tells us very strange, wondrous and fascinating things about the world. Really, the world as we know it, not just the Earth and the solar system, but the whole universe, but as at a point 1400 crore years back, 14 billion years back, they say 1 billion is 100 crores. Think, what an imagination needs to visualize that. Can you imagine the whole universe at one point? But that is what is Big Bang. The whole gigantic universe with its billions and billions of galaxies, each containing billions of stars. See, billion is already 100 crores and each galaxy has 100 crore stars. Wasn't even there as it is now, but was concentrated at a point called by the scientists the singularity. That is why this is a research subject. It's very staggering. Now this is a strange fact, probably the strangest of all facts in science. So we obviously need to ask why. Why was the whole universe at a point? The answer is incredible. And it lies in just understanding deeply the reality of an almost omnipotent force that governs the universe. We have already covered that in the section of gravity. That force is a force of gravity and it is universal. Let us proceed now to get a deep, real understanding of gravity. Since childhood, we have observed things falling from a height if left free. We have observed it so many times that we take it for granted, right? We do not systematize it or wonder about it or even feel it, right? Yet think, why should things fall? Tell me. After all, we are not pushing it down and there is no contact between the earth and the falling body. Isn't it strange? This action at a distance, you leave a body and it moves towards the earth. The earth is a sphere and all objects get attracted to the center of the earth and participates in the motion of the earth. Our atmosphere, the air we have, our ocean, everything is sticking to the earth, held on to the earth along the whole of its surface and circumference. The ancients wondered about the gravity. The real geniuses, not everybody on earth. But later, from 13th century onwards, people began looking at the heavens too and began wondering, and also additionally began tracing the motions of the planets, the sun and the moon. They collected a lot of data and bit by bit, they came to understand that it was not the sun that moved around a stationary earth, as the ancients had assumed, but it was the earth and other planets that move around the sun. This whole inquiry culminated in the Kepler's laws of motion of planets, which describes the regular uniform behavior of planets around the sun. It was not random or accidental. Then Newton began a serious, deep inquiry into this matter. Remember, it was very early. Nothing was really clear. The heavenly motions of the planets had been traced out. People observed the things falling on earth, but no connection was made between earth and heavens. It was almost as if then the heavens were different from the earth. Newton's incredible daring and genius lay in the linking of it, earth and heavens. As legend has it, he observed an apple falling on him and suddenly he got this great thought. What's that thought? Are the motions of the apples falling and the moon falling the same? The moon actually falls in the sense that if it did not fall towards the earth, it would go off in the straight line. It was already understood that the moon's motion, even the planets' motions, were a result of two motions, right? One horizontally, other perpendicular and vertical towards the sun. These two motions combined to give the almost circular motion of the moon and the planet, like how you move with a string something around your finger. All circular motion is a combination of two such motions. Well, Newton thought about this and he suddenly got it. He understood in a flash of genius that actually every mass attracts every other mass. He got the mathematics of it also. The power of attraction is directly proportional to the masses and inversely proportional to the square of the distance between them. Now what does this mean? This simply means the more any or both of the masses, more the attractive force. That's all. Greater the distance, lesser is the attractive force. Also, the reduction is the square of the distance. What does this mean? That is, it means if the distance is doubled between two masses, the force is reduced 4 times. If the distance is tripled, the force is reduced 3 to 3, 9 times. There's a meaning of square of distance. This equation fitted with Kepler's equation, and Newton made the heavens and earth one. Just think what a law Newton's universal law of gravitation really is. Every mass attracts every other mass in the universe, and Earth is merely one such mass. And this law holds true for all the masses of the universe. Even two objects on Earth actually get attracted because of that. So see, the Earth and the heavens became one. The reason we do not see a visible movement is because the attractive force of gravity is very, very weak. Unless the masses are of big size, there is not much attraction. That's why two chairs beside each other don't attract. This is the reason why things fall slowly on the moon. The mass of moon is 1/6 of the Earth, and hence the gravitational force, as it is called, is also 1/6. That is why we see that wondrous slow motion like falling of things on the moon. In space, things do not fall at all. They just so-called hang there where they are. This is because the object is too far from any big size object to feel any attraction. So, it just remains where it is. Isn't this a wonder? Newton had literally swept the space clean and unlocked one of the deepest mysteries of the universe. Now, still a major, in fact obvious question remained. If every mass attracts every other mass, then how can the world be, as we see it, our planet stars, be at all, right? How can it be at all? Should they not actually be together, this whole universe, at one place? This was seriously asked or wondered about in the 1900s, and no answer existed, obviously. The question, however, remained. If every mass attracting every other mass, then how comes each planet is happily independent? Then in the 1900s, another strange fact came into light. Scientists discovered that the universe as a whole was expanding. Every object was going away from every other object. You get it? They came to know this by a phenomenon called Doppler effect. Doppler effect is very common with respect to sound. Sound consists of waves, and if a body making sound is approaching you, the waves crowd together and the number of waves per second, that is frequency, increases. The opposite happens when the body making the sound is moving away, going away. Here the waves are more stretched out and the number of waves per second is less. Frequency is less, pitch is less. That is the frequency is decreased. Now the interesting thing is that light too is a wave. And the same thing has been tested to happen to light also. A body emitting light, if it's going away from you, would change its frequency towards the red. This is called the red shift, the red spectrum. If the body is emitting light is coming towards you, the frequency is increased in the light shift towards the blue. This is called the blue shift. If you observe through countless experiments that whenever you observe an object in the heavens, a star or a galaxy that is emitting light, it is shifting towards the red. This means that everything is going away from you. This actually means that the whole universe is expanding and everything is going away from each other. It is then that they understood why the universe is not coming together due to gravity. Actually, expansion of the universe was countering gravity. Are you getting me? If the universe is expanding, then the whole universe must have been at a point. Why is it expanding? And there must have been a Big Bang. This is how the scientists indirectly came to the conclusion the whole universe was at a point, and then the Big Bang happened and it started expanding and expanding, and still it is expanding because there is nothing to stop expansion. After the Big Bang, within moments, this is another wonder fact, all in research area, hydrogen atoms were created out of energy, they say, and began filling the whole space. From these hydrogen atoms were born the stars, the galaxies, and the solar system. How this happened will be understood in the following sections. Formation of galaxies. We have learned that the whole matter of the universe was at a point 14 billion years back, and that there was a Big Bang. After the Big Bang, what happened? Simplest atoms of hydrogen and gas were formed, and they filled the blank space after millions of years. Because of the Big Bang, the expansion continued in all directions. But in many areas, the cloud of hydrogen gas were a little closer, and due to gravity, because it's more, formed huge regions of, it started attracting all hydrogen around it, slowly, more and more, and huge regions of concentrated hydrogen gas was created. These are the galaxies. Even in those regions, in some areas, hydrogen gas got even further closer and formed stars. When the stars died, they burst and again spread out. All the stars in each galaxy also attracted each other and formed systems of stars. The galaxies themselves attracted other galaxies again due to gravity. Sometimes they push into each other, giving various shapes of galaxies and also very complicated motions. These motions continue to this day. So you see, it's not just all galaxies expanding away from each other. They move themselves too, and the motions never stop. We live in a galaxy called the Milky Way galaxy. Sometimes in a clear night, we see a white spread in the sky. There is a Milky Way galaxy. And today, now we have with this latest telescopes, we can see the nearby galaxies, the Andromeda galaxies, like a beautiful picture. Our Milky Way galaxy contains our sun as just one of the billions of suns or stars. So you can imagine how huge just the Milky Way galaxy is, and now there are such billions of such Milky Ways, of such galaxies. So the size of the universe is, my God, literally staggeringly unimaginable. We can only feel it. You can just feel it. You can close your eyes and just feel it. That's the beauty of physics. The birth of stars. We have learned already that after the Big Bang, hydrogen gas filled the emptiness of space. We also learned that in some huge regions, galaxies are formed which are nothing but masses of hydrogen gas collecting together. In these galaxies are formed stars. In some regions, a little bit of hydrogen gas comes together in the form of clumps, and this begins a process that goes on. The clump starts attracting, due to gravity, the surrounding hydrogen gas. It becomes bigger and bigger and bigger. The more big it becomes, the more powerfully attracts all the hydrogen gas surrounded towards its center. This process goes on and on and on, right? The clump becomes bigger and bigger and bigger. Actually, it becomes very huge and attracts more and more powerfully. The more bigger it gets. Now, this whole attraction towards its center creates a very huge pressure. Imagine. Now, you know very well when you rub your hands, it becomes hot. Now, pressure is related to temperature, to the producing of heat. If you rub your hands hard, it becomes very hot. Wherever there is pressure, there is heat. Heat is nothing more than the internal jiggling and wiggling of atoms and molecules inside matter. More the pressure, more the temperature. If the pressure becomes huge, the temperature too rises to a very high level. This is what happens inside the clump, which becomes very huge. There's a huge temperature of actually 1 crore degrees really centigrade inside the star. This removes electrons from the atoms of hydrogen. An atom contains proton and neutrons in its central nucleus, and electrons orbit around it. A hydrogen atom contains 1 proton, 1 neutron, and 1 electron. When the electrons are removed due to the high heat, a process called nuclear fusion reactions takes place. Fusion means joining together, isn't it? In normal circumstances, a hydrogen nucleus cannot join with another hydrogen nucleus. This is because protons are positively charged, and if two nuclei of hydrogen come close together, the proton in one hydrogen atom would repel the proton in the other hydrogen atom. Two positive charges repel each other. We learned that in electricity. But when the temperature is extremely high, as we just explained, the repulsion is overcome, and the two nuclei actually join together, fuse together, and become another nucleus. This nucleus contains 2 protons and is the element helium. So hydrogen is becoming directly helium. So in the star, hydrogen starts becoming helium. In this process, a strange thing happens. Mass is lost and converted into huge amounts of energy. Now these are very clear, simple concepts, but very staggeringly, wondrous concepts, like energy getting converted to mass converted to energy. Huge amounts of energy with the formula E is equal to mc square. This creates an outward force from the center of the star, but there's another force too. Because the star is so huge, there is an internal gravitational attraction towards the center also. These two forces, the constant creation of nuclear energy outwards and the inner sucking force of gravitation, balance each other, and the star is born. How long does this last? Obviously, till the hydrogen is used up in the star. What happens when the hydrogen is used up? The star begins the process of death, isn't it? What is this process? What are all the things that happen when hydrogen is used up? Hydrogen is over. We will see that in the next section. Death of stars. When the hydrogen gas is completely used up to make helium, in some stars it goes on to make other elements also. Two things can happen depending on the size of the star. The process of death of a small sized star like our sun. When the hydrogen is used up in a small sized star, the outward force of nuclear energy stops. With that, then what happens is the center of the star shrinks, but the outward covering of the star sort of floats up like a huge flare. So the star suddenly becomes big and redder. This is called redder, and this is a red giant. Inside, helium now starts the process of nuclear fusion reactions again and becomes lithium. But this does not last long, as the helium is used up very quickly. After this, again the outward force of nuclear energy stops, and the inside of the star shrinks and the outside flares up as a second red giant. For a small size star, this is all. The red giant cools, the star becomes very small, the size of the earth, but more like almost like the size of the earth. It becomes very dense. This is the white dwarf and a kind of ending of the star. The sun, being a medium-sized star, will go through all these processes. After 4 to 5 billion years, that is, the sun also would die. Actually, it's only 1 billion, they say. The process of death of a big size star. Now, what happens to a big size star? For a large size star, too, the hydrogen gets used up and there is an outward flare. This is a huge blast and it is called a supernova. But here the difference is the difference. Inside the star, the helium becomes lithium. Lithium becomes the next element and so on, and there's a series of red giants. The second difference is what happens when the series ends. Remember, if the star is huge, the inner sucking gravitational force would be very, very huge and unimaginably strong. This huge force breaks up matter also, and the star, instead of becoming a white dwarf, becomes a neutron star. The star contains only neutrons. If the star is even more huge, we don't even get a neutron star. It ends up as a black hole, where all the matter vanishes due to the huge gravitational force directed towards the center, including light. Gravity here completely makes the matter vanish because light also gets sucked into the black hole. What a wonder, because light also is a thing. So this is the way, broadly and deeply and essentially, stars are born and stars die, and they are always getting born and they are always dying. Just imagine we are living in a universe, such a huge universe, which was, which always will be there, which is eternal. There is no other world. Of course, we are so conditioned by this concept of God and afterlife and all that, even if we don't believe in God, that we find this concept very difficult. But it's a fact, and we have to kind of accept it in our own way. The whole universe is there, and from there came this galaxies, and from that galaxy came Milky Way, and from Milky Way came the solar system. Just one small star and one small earth, and that one small earth. You and me, who are going to live for a while, 100 years or 80 years or 100 years, and even this earth will be for only 100 crore years. We'll live for 100 years, the earth will live for 100 more crore years, and this whole place is vanished. This is not a negative thing to be, it is a beautiful thing, poetic thing, and feeling thing to feel, and those who feel it live a beautiful life. Thank you so much. And this is quite a poetic chapter. This whole universe, we on earth are only a speck, and actually in a way very insignificant. So all our worries are not there at all. Just leave those worries and live happily. That's the kind of thing we... Now we come to the last section, formation of the solar system. There are two main theories that explain the formation of the solar system: the sun, planets, and asteroids. But the theory most widely accepted by all scientists today is the nebula theory. Long back, there was a huge mass of gas, dust, and ice in the region, which is now our solar system. At that time, probably due to a supernova exploding star, this mass was disturbed. A disturbance in the universe is dangerous because if masses get closer together, gravity starts acting and collapses the mass, right? This is what happened. This is what happened. The mass got closer together due to the explosion. The mass also starts spinning. Get the point. If you disturb it, it starts attracting and starts moving also. As they got more and more close while spinning and spinning, the spinning became faster. Slowly over a period of time, the whole shapeless spinning gas started becoming orderly. Slowly it became orderly. It became uniform. It became flat. Now this whole thing, exactly like a frisbee, like huge frisbee or cake, spinning very fast, round and round. It became slowly in certain areas. This gas itself got closer in some areas, again due to gravity, and slowly formed large bodies called planetesimals. Even more matter flying around stuck to these planetesimals, and slowly over a long period of time, each planet was formed, rotating and revolving around the sun, and we got the solar system as we know today. That was formed, and that is the sun at the center, and the planets Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We have seen the wonderful pictures. You can go to the net and see hundreds of these pictures. It's all real and true and beautiful also. The question now remains as to how the sun was formed at the center. At the center, the pressure was very high, and the temperature rose to lakhs of degrees, and the process of formation of stars started. There's hydrogen becoming helium and releasing nuclear energy outward. This nuclear energy balanced the inner gravitational force, and the usual way the sun became stable. There's a big gap between Mars and Jupiter, and this gap is filled with numerous smaller particles. They didn't become planets, which is called the asteroid belt. Why was that planet not formed in this gap? This is because Jupiter is a huge mass close to the sun's mass. So if any planet tried to form itself, it was burst into pieces by Jupiter. Thus we have this beautiful solar system with the sun at its center and planets going around it. And that completes this wonderful, wondrous chapter, almost like a poetry called Our Universe. Thank you so much. We'll meet in another video with another topic. Thank you.